Good morning, Santula.
Good morning.
Good morning, Santula.
হ্যাঁ, গুড মর্নিং।
মর্নিং। বলছি যে হ্যাঁ মর্নিং। তোমার ওই যে যদি ঢুকে থাকে স্টার্ট করে দাও তুমি।
কোথায় কেউ কি ঢুকেছে? দেখছি।
কেউ জয়েন করেছে? একজন জয়েন করেছে।
আর আমাদের সেশন চেয়ার?
আপনি তুমি সেশন চেয়ার। আর একজন নেই।
আরেকজন কি বিজয় কুমার ডালা? বিজয় কুমার ডালা
নেই, কেউ নেই স্যার। তুমি সব, ওরা কেউ আসছে না।
কি হলো তাহলে? আচ্ছা, তুমি তাহলে একটু ইন্ট্রোডাকশন দিয়ে দাও। তুমি তো আছো লাইনে, তুমি একটা ইন্ট্রোডাকশন দিয়ে দাও, তারপরে না দেখছি কি করা যায়। ঠিক আছে?
ওকে। গুড মর্নিং এভরিওয়ান। I think only welcome all our session for production management. So in this session, Das from Jalpaiguri Government Engineering College is our session judge. So now hand over to Santanu sir, please. Thank you.
Thank you,
Please start, sir.
Okay, thank you, Arijit.
Okay.
In this session, as per our plan, 3 papers will be presented. I'm reading out the paper IDs. The first paper is PM1539. So, is there any author present over here who will present this paper? PM1539. Then we have PM1554. Then PM1565. These 3 papers are to be presented in this session. So I'm requesting the participant, if anyone of these 3 papers is present, so who is willing to present any of these 3 papers is most welcome, and you may start presenting your paper. So I think there is Satyamev Jayate. Who is this? Satyamev Jayate.
Hello.
Are you a presenter?
Good morning, sir.
You are a participant?
Yes, sir. Pavitra Singh.
Your name is Pavitra Singh. So
yes,
you
sir.
know your paper ID? You
yes,
have
sir.
the paper ID with you? So could you please
39.
tell me the name of your paper that you are going to present, or the paper ID of your paper?
Sir, my paper name is Study of Agricultural Product Drawing in a Slitless Rotating Fluid Bed Dryer with Static Geometry.
Okay.
And ID is 39.
Okay, ID is 1539. So without wasting much time, I'm requesting you to start presenting your paper. You can start sharing your screen if you have the PPT with you.
Yes, yes.
I'm sure that you have the PPT with you, so you can start presenting your paper. And
Yes,
remember, you have 10 minutes in your hand to present your paper, followed by the question answer session. So you may proceed. Okay, you can start sharing your screen and
yes, sir.
present your paper.
Yes, sharing option. Sir, are you getting?
Not yet. Now it's okay. Now you're about to. Yes, PCing. You are PCing, and your screen is visible and your audio is clear, so you can start.
Good morning, all of you. Today I am going to present my paper on the topic Study of Agricultural Product Drawing in a Slitless Rotating Fluid Bed Dryer with Static Geometry. So actually, India is the second largest rice producing country worldwide, while the Southeast Asia stands first in the rice production. So India actually cultivates around 273 million tons of food grains, for the our Indian population, which is around 130 crores. So out of this food grain production, paddy is 109 million tons, wheat 97 million tons, pulses 22 million tons. So in 1986, Nagaland Pellet reported that around 10% of food grain is lost during the post-harvesting processes, and out of these losses, around 1 to 5% of food grain is lost due to application of improper dyeing techniques. So it is a big loss of Indian currency, which is around 4,000 million rupees. So this loss can be reduced by using an appropriate or efficient dyeing techniques, and rotating fluid bed dryer with steady geometry is one of these dyeing techniques. So actually, it is a very compact size reactor. It is a totally static kind of reactor. It is very small size reactor, and a large amount of heat uh, transfer through this reactor. Due to higher heat and mass transfer, it makes the drying process faster. So, due to its static nature, there is no moving part in this reactor. So, the particle breakage is very less, which improve the grain quality. So, actually, this reactor can be used in multiple drying operations, such that paddy, wheat, coriander, tea, etc. And the maintenance cost is also very low because static kind of nature. So there are different other applications which can be performed in this reactor: separation, mixing, agglomeration, particle coating, drying, and combustion. So actually, the drying is nothing but it is a moisture removal process. So actually, you can see in this figure, this is a particle or food grain kept on the surface. Hot air is supplied across this particle, and the moisture of this particle first evaporates, and the air carried away this moisture into the surrounding. So this process completes in two regimes. First is constant rate period A to B, and second is falling rate period B to C. So during this first regime, the moisture of the particle remain wet, and the free surface moisture of particle at the surface is evaporates. And B is the critical moisture content point. At this point, the moisture removal rate is ceases to be constant. Further, falling rate period starts from B to C. So during this period, vapor pressure at the particle surface falls below the saturated pressure. So during this regime, the internal moisture of the particle starts evaporates. So EMC is the equilibrium moisture content line. So actually, fluidization is a technique of making a solid granular behave like a fluid. So actually, in this drying setup, this is electrical motor, this is blower, this is coupling, air bypass valve, air control valve, this is orifice, U2 manometer, and this is air heating chamber, this is air distribution chamber, and these are multiple air inlets, and this is main reactor. And this is solid bed region, and in white color it is freeboard region. This is solid inlet, and this is solid outlet, and this is centrally located chimney outlet. So actually these inlets are arranged in tangential direction. So air is high velocity air is entering in this reactor, which creates vortex, and the solid particles which creates the vortex, and we need to inject the solid particles when the vortex is created. So the air entering in this reactor is continuously flowing out through this chimney outlet, while the solid particles are forming a solid rotating bed, and till the end of the process, these particles will be in this reactor. So the proper fluidization depends on the forces: gravity force, drag force, and centrifugal force. If these forces are not in balance, then the solid particles may escape via chimney outlet, or the fluidization may be suspended. So in this figure, this is three-dimensional figure. This is the front view, and this is sectional view of this blade inlets. So actually in this figure, you can see the direction of gravity force is vertically downward in all locations, right side, left side, top and bottom, while the drag force is towards the chimney outlet, and the centrifugal towards the chamber wall. So this is sectional view. So actually air is entering in this reactor. It is shown in green color, So it is continuously entering and leaving this chamber via chimney outlet, while the solid particles in red color are rotating in this reactor. So this reactor is developed by using the concept of Kochetev, 1969. He has given this relation: force ratio lambda is equal to centrifugal force upon drag force is equal to ns upon pi d, where n is the number of slots, and s is the slot width, d is the internal diameter of the chamber. So the value of lambda should vary in the range of 0.0252 to 0.038. So we can calculate the tangential average velocity using this formula. So during the measurement of moisture content in the particle, we can use these two formulas on the wet basis, on the dry basis. So mc wet basis is equal to mi minus mf upon mi into 100, and mc dB is equal to mi minus mf upon 100. Sorry, mf. So into 100. So mi is the initial moisture content in the particle, while the mf is the final moisture content of the particle. So using these two formula, we can calculate the percentage of moisture in the particle. So actually, in this slide, there are two vortex chambers. First is with slits, and second is without slits. So actually, in the first case, the air inlets are arranged in transverse direction, and these inlets are of circular cross section. In second case, inlets are arranged in tangential direction, and the cross sectional area is rectangular. So in first case, the area of cross section of solid bed is rectangular, while the air is entering through the circular inlet. So at the corner points, the proper mixing of air is very low, and it is improper at corner points. While in second case, the cross sectional area of air inlets and the cross sectional area of solid bed both are similar. So the mixing of air with solid particles is proper. So it gives uniform bed thickness. Due to uniform bed thickness, the air requirement is reduced. So energy requirement is reduced. It means efficiency is improved. So these are the results. Effect of air inlet temperature on the drying time. So on increasing the temperature 55 to 65 degrees centigrade, the drying time is reduced by 18.6%. So we can say on increasing the temperature, the drying time is decreasing. But increase of temperature beyond the 65 degrees centigrade, the nutritional value and texture of food grains is decreased. That's why we will not prefer the temperature beyond the 65 degrees centigrade for the paddy. On increasing the airflow rate 400 to 600 meter cube per hour, the drying time is reduced by 20% at the temperature of 60 degrees centigrade. So deep and faster drying is obtained at the higher airflow rate due to the higher gas solid slip velocity, which increases the heat and mass transfer through the solid particles. On increasing the inventory 300 to 500 gram, the drying time is increased by 30% at the airflow rate of 500 meter cube per hour at the temperature of 65 degrees centigrade. So in this case, we can see that on increasing the inventory, the drying time is also increasing, but the percentage increase of the drying time is less than the percentage increase of the inventory. So finally, on increasing the inventory, drying time is reduced. So this is the graph which is showing the air requirement in the drying process. So actually it is increasing with increase of inventory. So it is 300, 350, 400, 450, and 500. So for the three inventories, this air requirement is shown in this figure. So solid bed thickness and bed uniformity both are improved in this reactor by replacing the air inlets round cross section to rectangular cross section. So the moisture removal rate is increased with the increase of the temperature, airflow rate, and the inventory. So finally, I would like to conclude. The cost-effective elements blade slits is removed from this reactor. So by removing this blade slits, it is very costly. So drying time is reduced, air requirement is also reduced, cost is also reduced, complexity is also minimized, energy requirement is reduced, and finally the drying efficiency is improved. So these are the references. Thank you.
Thank you, Pavitra.
Yes, sir.
So you have nicely presented your work, but what I personally see is that in your manuscript, in your paper, you have
Yes, sir.
not given any photograph of your original setup, right? So you have
Yes.
given schematic
Yes.
diagram. So since you
Yes,
have
sir.
developed the entire setup in your laboratory or
Yes,
in
sir.
your
Yes, sir. Yes, sir. I can show you. I can show you right now.
yeah, it would have been better if you can show us the overall experimental setup
Sir,
that you have developed in your laboratory.
if you give me 20 seconds, I can show you.
So because you have studied the performance of your experimental setup under three different conditions, what I can see. The
Yes, sir.
first condition is that the effect of inlet air temperature on drying time. Then
Yes, sir.
you have studied effect of air flow rate on drying time, and finally
Yes, sir.
the
Yes, sir.
effect
Yes,
of solid loading. So these are the three different
yes,
cases that
yes,
you have studied, and you have
yes, sir.
nicely
Yes, sir.
presented your work.
Yes, sir.
But
Yes, sir.
which is lacking is the absence of the original photograph of the original setup. Okay, so that inclusion of that part could actually uh, improve your
Sir,
quality of
sir,
your.
sir,
Mm,
are you? Can you see this? It is visible.
yeah.
So this is my setup, sir. Original setup. This one.
All right. All right.
Can you see, sir?
So why didn't you include this thing in your manuscript?
Sir, actually, I
Because
forgot it.
because you have just given the schematic diagram, right? So
Yes,
it would
yes,
be
yes, sir.
more convincing if you can include a few of such photograph, because these are the
Yes,
photograph of your original setup. Fine. So
yes, sir. Yes,
you have studied the performance under three different conditions. Huh?
yes, sir. Yes, sir.
So
Yes, sir.
I encourage you to include such thing in your paper in a future
Yes,
research
sir.
or
Yes, sir.
presentation, right?
Sir,
Okay,
sir,
that's it.
actually, I developed two setups. So physically, I am not mentioned in this PPT, sir.
All
So
right.
I'm very sorry, sir. Yes, sir.
Over to other members who are present in this
Okay, sir. Okay.
platform. I encourage others to throw any question to Pavitra.
Yes, sir. Yes, sir.
So others members are welcome to ask any question to Pavitra.
Yes, 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 sir.
Dr. Nimai Mondo, could you please ask a few questions?
And sorry, this is Dr. Nimai Mukherjee. Anyway, I was
Nimai
late.
Mukherjee.
I in between the presentation, I was there, so I cannot follow the whole paper anyway. But out of his presentation, it was appeared to me it is a good presentation, and he has done a lot of work, and he has taken a strain. Anyway, some scopes of improvements are there, and that has to be incurred in his future scope of studies or in future work. That's all for me.
Okay, thank you, Nimai sir.
That's okay. Thank
Thank
you.
you. That's it.
Shantanu.
Thank you, Pavitra.
Okay, sir. Thank you, sir.
So, is there any other presenter?
Uh,
I don't
so,
think there any other.
Dr. Shantanu, if you allow me out, then I can present myself. Okay.
Okay, so next paper will be yours.
Okay. So I am
Please,
presenting
please.
from the PDF from my. I am sharing the paper initially. Then.
No, you can start sharing. You can start sharing your PPT. You don't need to share your paper. Better you start sharing your PPT. Huh?
No, I would share the. I would present the paper from the PDF version itself. So in that way, let me try it out once again.
Okay, please go ahead.
One second. So I think the paper is now visible. Dr. Shantanu, is it? Can you see this sharing? Hello.
So now it is visible. Now it is visible. Your paper is visible.
Okay, okay. So
and could you please tell me your paper ID?
So my paper ID is this is 1554.
1554.
PM 1554. So good morning.
Please go
Good
ahead.
morning. Good morning to all of you. Dr. Shantanu and other members present as audience. So basically, this paper is a work of our MTech students, and this is being presented by me, myself, Dr. N. Mukopadhyay, Assistant Professor Selection Grade and Head Training Placement, JGEC, Job Examining College. The name of the paper is a cost-effective management study of North Bengal tea industries. Now, the motivation of the work comes like this. So, the tea industry is a almost 200 years old industry in India and specifically in the northeast part of India. Through the British uh, people, these tea industries came to India, and it is almost, this is 1838 to 35. This tea industry has been set up, and initially it was set up on the Assam region. But though a lot of time has been spent, the conditions of this tea industry peoples are very grave conditions. The cost of production is increasing, but at the same time, their remuneration is not going uh, at the higher uh, scale. Hence, a lot of industrial unrest problems are going there in the tea industries, specifically in this northeastern part of West Bengal and northeastern part of India. So the motivation of my work was this: on behalf of engineering studies, can we do some sort of contribution, effective contribution, so that some little steps can be taken to improve the situations of these tea industries. Now, as per these tea industries concerns, the problem can be attacked from two ways. One is improvement of their efficiencies of the machines involved, and the second way is to reduce the cost of operations in all ways. So, in these studies, we have tried to make a case study on how to reduce the cost of operation uh, for these tea industries as a case study, specifically for Goodrick tea industries just beside our JGC college campus. We have studied so that reduction of the cost would in turn increase the productivity of the tea industry itself, and if the profitability of the industry increases, definitely the economic situations and uh, the day-to-day wages problem might be met to some extent. So that was the basic motivation of this study. Now, one more interesting thing about this one. So nearly 51% of workforce in these industries are basically the women populations are doing. So in that way also, the government is also encouraging so that the women empowerment is there and their problems are solved to some extent. Now, though this industry is a big old industry of 200 years, but while studying this industry, I have seen the little amount of development was there in terms of technical improvements or the awareness uh, of the machineries involved in these tea industries. And as a result, what is happening, the same old machines are working with the old philosophies, and the cost effectiveness is very low. So in that situations, a lot of awareness and inculcation of new fresh ideas of technicalities are improved. So that is the basic things. Now regarding this operation of these tea industries, I would say, let me come to this area. So for the for reducing the cost of operations, we have to know the different ways of operations that specifically for CTC tea process concerned has to be there. So some processes are there. So while the teas are plucked from the garden, then it goes under certain processes, namely withering process is there, followed by rolling, fermentation, drying, sorting, and ultimately uh, grading of these things. Now, out of this all 5 or 6 process, in the withering process, what happens? The tea from the green tea leaves are plucked from the garden itself. It is kept on the trough, and in the trough itself. So let me. I have one schematic diagram regarding this one. If I can show this diagram. So basically, though these tea leaves are kept on this trough, and this hot air and cold air mixture are allowed to pass through some pipelines. Now, when this uh, hot air comes to this one trough, some porous trough is there. It's just like a tray, and on this tray, these tea leaves are collected. Now, this hot air, as being is lighter, it goes upward, and while going upward, it the heat and mass transfer takes place. So basically, so initially the tea leaves, which was of 80% of moisture content, it would be finally the moisture content should be near about 3% like this one. So basically in this zone, basically it is a heat and mass transfer problems concerning the mechanical studies. So while concerning this heat and mass transfer problem in the trough, this is withering sections. So that is another part of the work. But in this work, basically we have tried to minimize to make a energy studies so that some amount of cost can be reduced. So we in this study we have not gone for any mass or heat and mass transfer problem. Rather than we have make an energy study involved uh, so that some sort of energy can be saved, and by saving the energy some amount of rupees can be saved. So thus the productivity of cost productivity can be increased. Now this is a schematic diagram I have told for the withering section itself. Again I am saying this one. The hot air is coming from there, from this is and so one is this is the leaf bed, and this is cold air. This is cold air. This is number 4, and warm air. This is warm air is coming. It's a mixing chamber, and some fans are there, and these fans are forced fans are allowed this. So this is hot air to pass through this one, and it goes upward, and by this way, this heat and mass transfer is takes place. That's it. That is the basic things in the withering sections. So after the withering sections, the other sections are this is rolling, fermentation, drying, sorting, packing. I have already told it out. So all these sections are very much important. Hmm. So withering sections, and this is CFM means continuous fermentation machines are there. CTC, basic CTC means this is crushing, tearing, and cutting. This crushing, tearing, and curling of leaves process there. So that is the basic operations for the tea industry itself. But we have made a study on the economic part of this viability of the plant. So we have made a study. So how to reduce the cost in that situations? We have seen some of the areas where a lot of thought can be given so that the cost can be reduced, operating cost can be reduced. So first one is to increase the efficiency of tea industries, use of energy efficient nylon blade fans instead of aluminum fans. So while studying this plant operation, we have seen these aluminum fans, force fans with aluminum blades are there. Now we made a comparative study. If we see this one, so in place of this aluminum blade, if we take the nylon blade, see, so as the nylon blade, the weight of the fan reduces. This airflow and this trap size is same, but as the weight of this fan gets gets decreased, this nylon component, so motor capacity of the motor operating capacity is also can be used at a lower level. So saving of the energy, electrical energy is there, and so as the energy is saved, some amount of, we have make a study and see that energy per day in the tune of rupees 5,000 can be saved by just uh, uh, replacing the aluminum blade fans by the nylon blade fans. So this is one point, that is use of energy efficient nylon blade fans instead of aluminum fans can save 5,000 rupees per day for the plant. Now, in the same way, the second point is uh, in, use of dual speed fans instead of single speed fans. Now, in the withering situation, what happens? Total amount of green leaves are allowed to be rested on this withering trough. Initially the weight is more, but as the time goes, due to the heat and mass transfer away from the leaves and the reduction of the moisture content in the leaves, its weighs it weights gets decreased. But what happens if we use single speed fans or dual speed fan? In case of single speed, that is actually happening. So single speed fan, it is operating for 16 hours at 5 HP, can be replaced by dual speed fan uh, in operating in two shifts, 8 hours at 5 HP, and for 8 hours at 3 HP, because while the time passage, as the humidity contents of the leaves gets decreased, there is no requirement of use of higher HP fan. So in this way, some amount of almost we have seen this is uh, some saving almost this is if we use single speed fan of the cost amount 13,000 and 10,000, that is difference of 3,000 rupees we can save just by using dual speed fan instead of single speed fan. So next point is optimum loading of withering trough. Now it is seen that the for the withering trough situations, the optimum loading is 3 kg. So it, because in that some conditions are there. So now standard 6 feet by 50 feet length the trough, if it is used, and if 3 kg per square feet is the loading, then this is the optimum things. So for this is 3 kg loading for the trough situations. But as we increase the loading on the trough, definitely the HP requirement is high, and we have made a comparative study of using 3 kg, 4 kg, and 5 kg. That is also a matter of fact that using the optimum 3 kg, one second. So using the optimum, this is 3 kg loading on the definite same size of trough, we can save some amount of electric power. So that can be saved. So that is there is so this sort of saving is also obtained from the just optimum loading in the trough situations. Now another point is impact of the quality of leaf on energy consumptions. Now the leaf quality can be a fine leaf and can be a coarse leaf. For the fine leaf, see, for the fine leaf, the withering time is less, withering time is more. But if the leaf is coarse, then the withering time is more. The more withering time means for more amount of time, the fan should be in operating situations, and electrical energy would be consumed. So by this also, so if we can use better quantity of this is finer leaves, the energy consumptions can be saved to some extent. So here we have also seen that some sort of money can be saved by using the finer variety of leaf than the coarse variety of leaf. So now the next point is use of automatic start delta starter in motor. So normally in this industries, only start delta starter motor is used. But we have seen if we can use some automatic start delta starter motor, then some amount of money can be saved also. So this some calculations has been made, and it is seen that cost of saving in the tune of rupees 5,000 approximately out of the study it came out. So as a whole, we have seen that we can save 15 to 20,000 per day just by doing these sort of simple steps, amounting to 60. This is 60,000 rupees in month, and uh, almost 70 lakhs rupees per year. So that is a huge amount of money in terms of industry, where the industry cannot pay the minimum wage to the workers itself. So this sort of if this sort of awareness is given to the workers, to the management, a lot of things can be, a lot of money can be saved. So in the conclusion, I would say, so whenever I have discussed this sort of things to the management, team management, to some extent they are convinced about this, that we can save a lot of money. But they have also facing one problem, that from where the initial investment should come, replacing the age-old machines with the newer technologies definitely have a uh, costings are incurred. So in that situation also I have told them, so if it would be better if they can do it on a staggered approach, uh, instead of replacing the whole machineries. So staggering of things can be done in a phase-wise manner. Some awareness can be, definitely awareness drive can be there. So a lot of money can be saved, and definitely the laughing face of the tea industry workers can come out of this study. So this is a continuous study, and we are still doing the heat master transfer studies on this one, and a lot of research, more work has to be taken out of to go into the deeper and the finer sides of the things. So, and as for the reference itself, we have taken the reference from these papers, and definitely these last papers from the IIT Kharagpur professor, Department of Agriculture and Food Engineering, uh, had given us inspiration for carrying out this sort of work. And so that is all, and thank you for allowing me to present the paper. Over to Dr. Shantanu.
Thank you, Dr. Nimai Mukhopadhyay, for presenting uh, a paper which is really relevant in the context of the North Bengal socio-economic situation that is prevailing now. So, going through your paper and observing a presentation, a few points have been identified. First thing is that you have gone through a rigorous study of the tea industry operational steps and the different schemes to save money from different operating arrangement. So firstly, the point that has been identified is that you have studied the energy saving aspect
Right.
mainly on the weathering section, right?
Definitely,
Only on
definitely.
the weathering section, because obviously in the context of heat transfer issue, this is the most relevant one. So in the weathering section, you have proposed few schemes to save money. Okay, and the point that has been identified that whether these schemes are practically viable for the owners of the means whether these schemes are practically viable to adopt at this point of time by the owners of the tea industries. So that is the main question, because you need to
So
motivate them. You need to motivate them to incorporate such things in their factory. First thing that they will be facing is that their age-old mechanism. Obviously, that as per your suggestion, the age-old machineries are to be renovated or upgraded by, or needs to be replaced by new models or new techniques, new technologies. So that is the first hindrance for the
Right.
is the first hindrance for the owners. Okay, so they will not get motivated. So that is the main problem that we'll face, I think. Hmm. Because you
Right.
need to convince them, because your paper deals with the operational cost only. You have not given any suggestion regarding the upgradation cost. How much cost
Right.
need to be added or need to be borne by the owners to improve their technology, overall technology that they are actually going with. So
All right.
mainly operational costs are dealt with in this paper. Means you have dealt with the operational cost only. So
So
it would be
further
better
studies
for you
required
to,
also in that
yes,
area
yes,
also.
further scopes are there. So that's the
There.
first thing that you have actually studied the energy saving aspect in the weathering
Right.
section. But I would be very means rather most of us would be very uh, interested. We are mainly
Right.
interested on the overall section. Means overall means the energy saving. Means overall solution for the energy saving. Overall solution, so that the overall
Right.
cost, main cost can be saved. Overall cost can be saved. So there is crashing section. There is other sections in the
Other sections
factories.
also. Right.
uh, and you have mentioned in one point, you have mentioned that dual speed fans are to be required in
Right.
one particular solution. But
Right.
what we have, being an electrical engineer, we
Right.
have a different solution, right? We have different
Right.
solution that is called the variable frequency drive. Using a single motor, it is possible to operate it in a different speed as per requirement. So that is
Okay.
called the VFD, variable frequency drive. So this
Okay.
technology is there now. It is an emerging field
Okay.
and it is available now. So without, I mean, instead of going for two different motors, having two
Right.
different ratings, it is better to have a single motor and operate it in at a different speed as per requirement. So that
Right.
kind of technology is there. So
So
that can
saving
help.
of a lot of
Yeah,
amount of money can be saved
amount
also by
can be saved.
VFD, right?
Yes,
So
yes,
that is
by
also a good
VFD.
thing from the
So
electrical engineer side.
that is a better solution. That would be a better
Okay.
solution instead of going for two
This is dual
motors.
field dual
Yes,
speed option.
dual speed option. That
Right.
option can have a better solution. Okay,
Right.
you can suggest a better solution for that. So that is
Okay.
my opinion as per.
No, definitely.
Uh,
I'm noting it down out so that in my
yes,
future
so
work
that
we
technology
can
is there,
replace
and
by the
another.
VFD.
Yes, that can be replaced by the VFD because it is
VFD,
a
right?
very good solution nowadays. Because after the introduction of VFD, you have seen that in the traction field,
Right.
the age-old DC motor technologies have been replaced by variable speed drive. Over there, you can use induction
So
motor.
a
So
lot
that
of
kind of
scopes are there for improvement from
lot
the
of scopes are
electrical
there. This is
sides
one of
and the mechanical side.
the electrical, because the energy saving aspects were mainly concerned with the electrical. Means
So
you need
that is the
to,
electrical domain
yes,
also.
you need to take care of the electrical motors.
Domain also definitely.
Electrical domain also. So that is one thing. And another point is
Hmm.
that the quality of leap. You have at some point you have mentioned the
Quality of leaf.
so quality of leap is not in the hand of the factory owner. It depends on the season. It depends on
Seasons.
the season. So you have to go with that. You have to go with
Right.
that. You cannot suggest the owner to use better
Right.
quality
Right.
leaf throughout the year. It is not possible. They will
It's
actually
not possible.
throw out your
So
solution.
practical limitations of that problem is there.
Practical limitations are there because the
So there.
first leap, second leap, and different types of
Hmm.
leap qualities will be there, will be
Right.
supplied to the factories, and they have to accept at some in different time to
Right.
run their factory. They have to accept that
Hmm.
varieties of means quality may differ at point means in during the season.
But at
So
least they should be aware of this one by using the
yeah,
better
they know
quality.
that
Then
they know that
right.
they know that because
Right.
we have come across few of the means we have interacted with some of the owners, and they are
Right. Right.
actually quite aware about these facts that they are dealing with all these age-old technologies. They are having motors which are mostly overrating. That is
Overrated
another point
motors.
that you can note down, that most of the motors are having rating which is
Overrated
greater
motors.
than the required, greater than the required motor, greater than
Required
the rating
motor.
of the required motor, required
Right.
rating.
Right.
So to be in the safer side, my point is that
Right. Right.
while selecting this kind of motor, they have, the designer must have taken a very high safety factor to be in the
Right.
safe side. they have taken very high safety factor. So that is quite obvious. To be in the safe side, you have to select a higher safety factor, but that will ultimately end up with
increase of
uh,
cost.
increase of cost. Okay, so these are the probable things, probable issues that you can incorporate, that you can
Definitely,
note
I
down,
would incorporate.
which will help
Specifically,
you to
that
come,
your this is
which will,
VFD thing is good,
yes,
and your that is
which
overrated motors that you are mentioning. That is also a
overrated.
area where we can reduce the money,
Yes.
this cost.
So that if you incorporate all these points, then you can come up with a better solution.
Better
Okay.
solutions would come.
Yes. So that is what we have. We can say.
No, that is a good suggestion. Definitely, I should
Finally,
take it
okay.
down.
Thank you for giving a nice presentation.
Thanks also for allowing me to
But
present this paper.
next time, it would be better for us to have
Thank you.
a different kind of presentation with conventional PPT. Uh,
Okay,
so we
okay, okay.
discourage
Anyway,
you to
that is
share
right.
the entire paper, PDF
Because
paper.
initially what happened, I have told Aditya to present it out, and but he has some problem. He has given it out to me. So let me. I have tried to present it out. That should be good. The suggestion is good.
Very, very nice interaction this time. Thank you. Thank you.
Thank you,
Okay.
thank you, Dr. Shantanu and the team.
Over to Orijit. Over to Orijit.
Audit,
So
audit.
I don't think that
Yes,
the third presenter is with us. He is
yes,
not
yes.
there, I think.
The last presenter, I think he's not there.
He is not
So
there.
we can conclude here the session.
Okay.
Yeah,
So
please,
that's
please,
it.
please
That is the end of
conclude.
the session. Okay, thank you.
Okay.
Huh?
Thank
Yes.
you, Noim.
Thank
Thank
you,
you,
thank you for
Audit, for your all
the
efforts.
introduction.
And
Noim,
this
thank you. Orijit, thank you.
so
Thank,
Audit, Audit and
thank you,
Naim
sir,
and
for
team
helping us.
go on organizing this sort of seminars, and this is the
And
conferences,
especially, so
and
it would be
this
better if you can quickly organize few more
right.
conferences
Now the
like this.
team is ready. Now,
Yeah,
yesterday I was seeing that you have
Yes,
posted this
sir.
one where three mutual
because
sessions are going on in three laptops. That is a very
without
Yeah,
wonderful.
yes,
yeah,
sir.
without taking up much pain, we can easily organize such
Definitely,
conference, and
But
obviously the outcome of the conference will be quite good and
right. That is.
fine. Thank you.
okay, sir. Okay,
Anyway,
sir. Okay, sir.
good
Thank
effort
you.
from behalf of JGEC and from behalf of the Arijit and team. Thank you all.
Thank you.
Okay.
Okay,
Thank
okay.
you, sir.
I'm just signing off. Okay, bye.